Hello again. Today we are working on assignment 2B, and this is where you're going to be building your spaceship interface. You have written the code. You will upload the code to the board that you build the board, and you will make something. In the end, it'll look like this, right? This is what you should be shooting for. That's the goal. So, first of all, let's take a look at what you need to do in the assignment. To be to do. I like that. It sounds pretty cool. Write the code and verify and submit. And what I mean by submit is send a picture of your code. If it's a couple pages, take a couple screenshots of it showing that it's you doing your code. So write code, verify, and submit. Next up, build the board for the spaceship interface, which means do all the wiring, build the board, wire everything up, and submit a picture of that. Because sometimes you might have a project where you're really struggling and you might not be able to get the code to work or the board to be wired correctly, but you've tried. So always submit it. Even if you don't get to the last step where everything works together, doing these still counts for work. So always submit what you can. And then last, of course, you're going to upload your code to the board and submit a picture of it working like this. So submit it with the green light and then maybe show it with a red light on. Something like that, a couple pictures. And you'll submit them all to the assignment 2B in Google Classroom. No problem there. So you're going to write a code, you're going to verify and submit, and that verifying can be tricky. It can be very, 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 very frustrating. So get ready for that. And building the board, it's kind of fun. Take your time. It's very hard to find your mistakes. So if you don't take your time doing it, and if you're rushing and it's not working, it's on you. I can't come over to you. I can't rewire your board for you. I can't do any of that kind of stuff. So it's really you on your own, checking line by line of the board and line by line of the code. So now if you did the last assignment, now you have your login to Chrome, into the school account. You can go right here to that O and Arduino Create for Education, and your account will load up. Sorry about the blurriness, I know. It's not the best setup. It's a pretty old projector, but I don't like doing screen caps because they don't have audio, so it's a little awkward too. So I have written my code. I've written it twice, actually. I wrote 2 versions. And I just copied and redid some stuff here. Now, so the first thing you should do before you ever plug it in and upload it to this board is you should do something called a verify. Now, look at, if I verify it and I click it, it's doing stuff, everything works. Success. That's what you want. You want that success screen. But even if you have one little thing, like for example, that right there, if I don't have that right and I verify it, but it highlights where your errors are, and there'll be many errors if you've made a bunch, and you'll go line by line and see if you can find the errors in your code. So obviously it's expecting another closed bracket on this one. So what I would do is I made my mistake. I'm going to add a little closed bracket there because there's 2 of them at the end. I can verify it. Once you've got it verified and successful, take a picture of that. That is your first step of the assignment. You wrote the code, you have verified it. You haven't put it on the board yet. The board shouldn't be even plugged in at this point, right? The board should be unplugged. Next step, you are going to build this board. And notice the 220s versus the 10 kilo ohms. Notice the difference in those resistor colors. Everything's wired nice. I've used a little bit of longer cables, but I want to take this time now. I will upload this quickly, but so once you've done this, that would be step 2 here. Build it and take a picture. So take a picture of your build. All right. Boom. And lastly, the last step you will have to do is take this and you will upload it and save it. So I'm uploading it to the board. You can see it does a little flick on there. That means it's uploaded and it's done. Everything worked. Now when I do this, kaboom. Engage hyperdrive. And then I shut it off. All systems ready. Engage hyperdrive. But let's spend a couple minutes talking about what the heck you just made. Okay? Let's talk about this. So we're going to mostly spend our time down here now. Okay, so let's just look at the circuit for a second. Before we talk about anything, look at this. Every one of these runs to ground, but notice this. This switch has a wire here that goes to pin 2. So this switch, if you push it, look, we've got signal coming out here, and it goes to the switch from the positive. Because you can steal positive from anywhere, but our positive is coming from here to there. And if we push it, it goes there. And this wire sends it to pin 2. And it also, if we complete it, it also sends it through the resistor to ground. Now, that's the first part. Now we've got 3 wires running to different LEDs. This is pin 3, pin 4, and pin 5 coming out of 3, 4, and 5. So just look at the circuit. Look at what we're working with here. We've got this button that if we push it, it sends a signal to pin 2. That's the first thing. If we push this button, it sends a signal to pin 2, which is going to send pin 2 to sensing high. If it senses high, it will tell pins 5 or 4 and 5 to send signal to them every quarter of a second. Right? I believe that's what we wrote in the code, 250 milliseconds. So if low, which means I didn't push it, if pin 2 is low in your code, just power this one. If you push this down and pin 2 becomes high, it will send alternating signal to pin 4 and 5, which pin 4 runs to this, goes to that, and it goes, pin 4 goes to this one, pin 5 goes to that, and it alternates power to them. So let's look at how, remember, if I push this, pin 2 gets a high signal, and then it tells to alternate high signals to 5 and 6, or 4 and 5, and then 3 would become shut off, because 3 will shut off. So this is really pin 2, pin 3, pin 4, pin 5. If pin 2 is low, pin 3 sends high. That's what we've wrote in our code, folks. We told the code to do that. If pin 2 becomes high, which means it gets a signal, it tells in our code pins 4 and 5 to send high output alternating in seconds to those two. So do you understand how the wiring of the board, we've got a little, if this does this, do that, and it's coinciding with our code. Let's take a look at the code. So let's find that pin 2 in the code. So you've got your void setup. You've got the first rule is in your void setup, you're setting the rules. Pin 2 is going to be an input, so it's going to sense whether it's high or low. And you've decided that pin 3, 4, and 5 are all going to be outputs. So this pin's an input, and these 3 are outputs. Output, output, output. This output's on right now. These 2 are off. So you're setting up the ground rules in your setup. And then it says here, switch state digital read 2. So now we're talking about that read. We're sending that as a read, and we're saying digital read 2. So what are the rules for digital read 2? If it is low, which means the button isn't pushed, make 4 and 5 low and leave 3 as high as the green LED. So if the button isn't pushed, this pin senses that, and it leaves 3 high, low, low, off, right? Else, if the button is pushed, so if else means the opposite of whatever this code was. So switch state low, so else would mean switch state high. So else, if I push it, then make 3 low, make 3 low, make 4 low, make 5 high, and then wait 250 milliseconds and make 4 high, 5 low, and leave 3 as low, and then go back over and over and keep reading whether the button is pushed. So you should be understanding how the setup that we've made here, and then determining whether these are inputs and outputs, corresponds to what we tell those inputs and outputs to do in the code. This is pretty cool. honestly, you're setting up a circuit. You're setting some things to be inputs and some things to be outputs. Sorry about that. You're making some things input, some things output, and you're telling them, if this happens, send signal out of that output. If this happens, send signal out of these outputs, or don't send signal. And that's what this is. If that's not pushed, send signal to here through pin 3. If pin 2 gets a signal, alternate every 250 milliseconds between pin 4 and 5. I don't know about you, but this is the simplest project, the simplest code, and I still think it's so fascinating. It's very literal. It's very clean, neatly wired. You can see how the circuits flow. You can see that these are outputs and this is a reading input, and I wired the colors a little bit differently just to illustrate that for you. And the last thing that you could do is if you want to submit a picture of this, you could actually use the Spaceship interface, and I want you to try this, so do this for an extra picture here at the end. You can kind of smash these down, and if it breaks or you unplug something and it doesn't work and you can't get it, just show me that you tried. I'm going to give you a mark, don't worry. So you're going to put these through there. You're going to kind of put that down there. You might have to, like I said, you might have to mangle these a little bit, right? Okay, now I'm going to push that there. I'm going to put that down. All right, I've got my Spaceship interface, and it says system ready and engage hyperdrive. System ready, engage hyperdrive. Ooh. But I love the beauty of this code. I love the beauty of this wiring. I hope you're getting how you could set things as inputs and outputs and write code to tell those inputs and outputs what to do when certain things are sensed. We're going to move on to the next one, and the next assignment is just writing the code, understanding it, doing some questions, and then wiring the board, uploading it, and kind of like the same kind of process. But we're going to learn about new parts every time. We're going to learn about new pieces of code that we can do to use different things. We're going to learn about new components and motors and sensors, and they all have codes. We're going to learn about libraries because some of the parts that we put on our board, they're very specific parts, and they need a whole set of codes just for them. So that's where we get into a little bit more complicated things. But project 3 and 4 are kind of similar to this in difficulty, a little bit more interesting, a little bit more nuanced, but I think this is just a beautiful code. So I hope you've enjoyed it, and submit everything. So remember, write the code, verify, and submit a picture showing that it's verified. Build your board and take a picture of it, and then upload your code to your board and take a picture of it working, showing it work, and then take a picture with the Spaceship interface paper on. If you don't have one, you could cut one or make one or let me know. I can borrow you one. We could figure something out. This is just for fun, but later on you're going to be putting things onto your board like this, so you've got to get used to like, oh, this is a thing I can manipulate and mash the wires, and it still should work if I've done a good job. So I hope you've enjoyed. I love this stuff. We'll see you soon. Take care.